Hello, everyone. Thanks for being here. Hope you're having an awesome conference. So you're in the Building Next Generation Databases, Cloud Spanner Under the Hood session. I am Pratibha Suryadevara. I lead the Spanner engineering both for internal offering and also the cloud offering. To present the session with me, I have Chris Taylor, VP, Google Fellow, one of the original authors of the Spanner paper. It's a privilege to present with him. And I have John Fisher, who is Head of Engineering for Google Photos. Thanks, folks. Okay. During the course of the next 45 minutes, what we wanted to do is walk you through what Spanner is, why we started with Spanner. Then Chris will walk us through the technical details under the hood on what makes Spanner what it is. And then we'll have John walk through how Google Photos leverages Spanner. At the end of it, we should have about 10 minutes or so for Q&A. So I'd request all of you to line up at the mic if you have any questions. If you run out of time, all three of us will be available outside so we can have a chat after the session. So let's start with what Spanner was. So in 2009, as Google was one of the early disruptors on reimagining how the businesses should be done online, we actually faced 4 challenges. One is lack of horizontal scale. 2 is the frequent downtime the businesses had to take. 3 is the high operational toil the operators had to deal with. And 4 is the low developer productivity. Looking at the systems we had at that time, we came up with a conclusion that we needed to build a system like Spanner that has these distributed capabilities to kind of take care of these challenges. Interestingly, these are the very similar challenges that I hear from our external customers today. All of you, as you're building your businesses, you're disrupting whatever domains you are in, you face the same challenges. Around you're reaching out to your customers in different channels, the scale at which you're talking to your customers, the features that you're providing to your customers, you run into the same scale challenges. You're actually looking at the similar challenges around operational toil and also the developer productivity that you have. And the last piece is, as you build these systems, manually operating these, self-managing them becomes very complicated at a certain scale. So what we did was, let's build a database that our customers can trust. What do we mean by that? I think Spanner database as it built provided the highest availability in the industry today. It provides the horizontal scale that you need. It also has zero downtime that you look for your businesses. And also a lot of your businesses in retail and all need that zero downtime, especially in the environments you scale. So having that horizontal scale capability is awesome. Second, we wanted to build a system that you can innovate on, right? All the way from leveraging your existing skills. We provide open interfaces like Postgres. And also a lot of your businesses today don't run just one type of workloads. You have transactional workloads, you have analytic needs. The system and the architecture that we built gives you that environment where you can run hybrid workloads. Last, the third primitive I want to talk about is the productivity. Like I talked about earlier, a fully managed Spanner is what we build for our customers so that you can spend your time and your developer productivity on what's important for your business versus managing this infrastructure. So with this kind of infrastructure that we built, this is where Spanner is today. Hugely adopted inside and outside of Google. Today we have around 3 billion QPS running on Spanner, 12 exabytes of data under management, and the customers that we have, starting internal with Google, all the way from ads to YouTube to photos to Chrome to search to Android to GPay, and all the Google workspaces, calendar, Gmail, Maps, all of that runs under Spanner today. In addition, inside of Google Cloud, all the control planes for GCS, GKE, IAM, all of that is built on Spanner. For our external customers, all the way from gaming to retail to financial to healthcare to social media to transportation, these are all the external customers running on Spanner today. So we've built this amazing platform that gives you the reliability, the scale, the architecture, the extensibility that you need. Let me hand it over to Chris. He'll walk us to what we did to get to this architecture.
Thank you. Hi, my name is Chris Taylor, and I'm going to talk through the key pieces of Spanner and how they work together to make Spanner a great database for applications that matter. Really, we start with scale. Scale cliffs are scary. It's a failure at a moment when something good is happening to your business. And so we built Spanner to handle immense workloads. This was actually one of the easier things that we did because Google at that stage had lots of experience building exabyte scale storage and key value stores, and a lot of that same DNA is underneath Spanner. Along the way, we were really careful to make it work well for small users as well. We wanted this to be for Google's workloads of all kinds and our customer workloads of all kinds. And really, it's amazing seeing our customers feel safe, knowing they're far, far, far from any scale limit that we have. In high availability was sort of the next principle here. We had all used HADR implementations where you have a big bang failover, and it's kind of built as an add-on. You build the first system, and then you build a second one, and you fail over to it. The reality of the cloud in our experience is that at scale, failures are small but frequent. And a system that routes around these transparently and automatically works much better in practice. And so this is how we tried to do Spanner. We added fine-grained tablet-level failover, SQL queries that restart when they hit bad machines and things of that kind. And as a result, Spanner survives small, medium, and even large problems with low impact. We also carefully designed our just ordinary lifecycle events. Schema changes, software upgrades. These happen fully online. We have no notion of maintenance downtime. Spanner also offers multi-region capabilities. And this stems from realizing that the leap from one region to two or more is a big challenge for an application. Do you want to redesign with eventual consistency in mind? Do you want to have these rarely exercised monolithic failovers with the possibility of data loss? We aim to make geodiversity really as easy as possible. We built RPO0 replication, which brings you an extra 9 of availability. And we have the option to add extra read replicas near your customers for reduced read latency. We also, recognizing that not every customer that needs multi-region starts with multi-region. We implemented an upgrade from regional Spanner to multi-region Spanner that you can use when you need it. The transition is fully managed and online, so you can start small and build up. Another reality of working with big production databases is that traffic shifts are a reality. The usage of an application is hard to predict. Your app changes, the world changes around you, and as a result, the pattern of traffic to your key spaces shift. And often, the way you were sharded before is invalid a minute later. So with Spanner, we built strong insurance against those kinds of problems, both online scaling, so you can just add more nodes when you need to handle more traffic, but also fast inter-server load balancing and key range splitting. And these capabilities combined can turn most hotspots into non-events. Really, Spanner handles it, and you never even realize it happened to you. Many of these strengths come from Spanner's compute storage separation. We have one tier of servers that handles your queries, and another tier of servers that stores your data, called Colossus. And this lets us radically rebalance read and write loads on the fly without data copies. It also means that when one of your query servers is lost, you've only lost a small fraction of your cache, and you really don't even notice that this is happening. Separately, we have a lot of experience building key value applications. We've done many of them. We've seen how they grow up. The first 80% of a key value application is invariably easy and fun. It's a friendly way to model, and it's easy to see how the basic patterns of your application map. But it's very common in my experience that the last 20% of that app needs a few more things from the database. And this is where the long tail of these workarounds drives a lot of the complexity in the application. By the time it's done, it doesn't look as simple as how it started. Now, engineers, including myself, are very creative. Almost anything can be made to work if you try hard at it. But what we saw with Spanner is a big opportunity to make our customers more productive and their apps simpler and more maintainable. So I put up a subset of the features on here. I won't walk through them all, but many Spanner applications do stick to plain vanilla key values. And Spanner handles that very well. If you don't need more, the base system can handle your key value workload with good price performance and good performance. But we do see that many apps start that way and then eventually reach for a few more capabilities from the tool bag, whether it's transactions or indexes or a little bit of SQL or whatever. And we're constantly adding more here. We're working with our customers to understand what their most common design patterns are and where they're hurting the most. And we try to add features that can really take that complexity and bundle it into a beautiful package. A great example is something we've just announced, Cloud Spanner Data Boost. Many apps have fresh and valuable data, but it's locked away from analytics because of fear of the impact of those workloads on serving. We all know how this is commonly dealt with. There's ETL and extra copies of data or dedicated analytics replicas. With Data Boost, we have a third way. You can query Spanner from BigQuery or Dataflow or the analytics system of your choice with strong isolation and no fixed costs. So really, you're just paying for the usage of your queries. And this is, again, a consequence of compute storage separation. We're able to use an on-demand pool of query workers to run your Data Boost query the moment you give them, again, with no fixed costs. Also, because of this compute storage separation, we're often able to apply more resources to your queries and run them significantly faster through higher parallelism. This is an exciting example of a really common pattern needing to run analytics on your operational data that is more hands-off than ever. Sort of wrapping up here, we're trying to build the most capable scale-out database in the world. And we're not doing it because every customer needs every feature, but because when you start out, you don't know what you'll need by the time you arrive with your customers and really land your work. And we want you to be ready for anything. And with that, I'm going to hand back to Pratibha to show some of the ways Google has benefited from its no-compromise database.
Yeah. Thanks, Chris. Okay. Continuing, let me walk through some examples of a little bit breadth. First, look at how different applications and services inside of Google use Spanner. So like Chris mentioned, the tenants that we built Spanner with enables all of Google to run on Spanner. So today, like I said before, Google runs on Spanner, all the way from Google applications like Gmail, YouTube, Calendar, Maps, Ads, Photos, just to say a few. All the workspace applications, Gmail, Drive, Calendar, Meet, Sheets, Docs, and all the Google control planes for services like GKE, GCS, IAM, all of this run on Spanner today. In addition, we have Alphabet companies like Waymo and Verily also run Spanner. So let me walk through some use cases on why Spanner, what motivated them, and where are they today. Let me start with Ads. Ads was initially built as a self-managed MySQL workload. The scale to which they got became a problem where the MySQL was not scaling for them, and also the frequent downtimes that they had to do, whether to upgrade this stack or outages because of the scale, kind of became revenue impacting for them. This is one of the first applications we started working on Spanner, so we worked with them very closely. At this point, a lot of ads use cases, whether it's auctioning, whether it's giving ads to the web pages or their payment systems, all of them run on Spanner. It's been over a decade or so since ads been running on Spanner. We've not seen a single downtime that is revenue impacting with ads on Spanner. So the second application I want to talk to you about is YouTube. YouTube is another sharded MySQL, which was built on Vitess. They started running into challenges where both the cost of the infrastructure, because each of the applications they built, whether it is their music or streaming, each of them was built on different stacks. And also the downtime and the fragmented storage solutions was becoming too expensive for them. And their initial architecture was also built on the very challenging architecture on LAMP, which was not scaling for them after a certain scale. So they started migration to Spanner. So today, they launch multiple products like music, kids, shorts, TV on a single infrastructure, which is the most replicated data set across multiple regions, which is giving them a very high resource efficiency and operational simplicity. This is also helping them transform large processing pipelines for their business, things like spam filtering, things like personalization and stuff, which gives them the strong consistency they need across regions and also the security and privacy and compliance they need. Moving on, the next application I want to talk to you about is Google Pay. Google Pay in India, Google Pay is, as you know, a mobile payment service used for in-app, in-person, and also online contactless payments. Today, Google Pay serves around hundreds of millions of customers doing billions of transactions monthly. What was important for them was a low latency and massive scale. A lot of you in retail know that the scale, for the events like Cyber Mondays, Black Fridays, festival seasons like Diwali in India, is where your infrastructure gets stressed out and where your reputation, whether the system is scaling or not, and how it scales and how much preparation that goes into it becomes very critical for the infrastructure providers. So GPay today, they're able to scale because of the Spanner infrastructure. In addition, especially retail and financial customers have these regulations and compliance. So all of that is offloaded by Spanner for these customers. And another customer, our own information retrieval systems inside of Google. This system started more for indexing and serving the web pages, but over time, it became a multi-tenant infrastructure that's used for multiple corpus, public and private, YouTube, Gmail, Photos, bunch of these systems, right? These systems don't, at this point, just live with serving and indexing. They have to provide a lot more differentiated features. So having Spanner as this uniform infrastructure gives them the replication, the resiliency, the redundancy they need. And they're also able to quickly iterate on the features they need to build. One of the interesting things is because they've merged all these into a single system, all the bespoke solutions become one, and the infrastructure simplicity and operational simplicity is what is becoming simpler. On top of it, the search capabilities on Spanner gives them a single place for them to not only do serving, but they're able to do analytics and search. And also this opens up similarity search and AI use cases for them. The one last use case I want to talk to you about is Chronicle. This is in our security space. Chronicle is a Google enterprise service where customers can actually privately store, analyze, and detect any of the risky behavior in their network or security telemetry. So this system, again, is a single store they use globally, analyzing exabytes of data within sub-seconds of latency is what they get by using Spanner. With that, I gave you a brief overview of internal use cases across different spectrums, across different verticals inside of Google. Let me hand it over to John, who will give us a much deeper look at how Google Photos uses Spanner.
Thanks, Pratibha. Hey, everyone. I'm John Fisher. It's great to be here. I'm a Senior Director of Engineering at Google, leading engineering for Google Photos. So I'm sure many of you know, but Google Photos is the home for your memories. It's a photo storage, sharing, reminiscing service that offers a complete consumer user workflow across devices so that users can automatically back up, organize, edit, search, and reminisce about their most precious moments. And all of those are built with ML and AI at its core. Google Photos has a global user base with over 1 billion monthly active users, and our corpus size is over 4 trillion photos and videos. And so Photos needs a database that can scale to that size across a wide variety of read and write patterns. And so for photos, that database is Spanner, and we store tens of petabytes across dozens of geographies to serve our users. Let's look at the life of a photo as a user captures it and goes up into our systems. So a user captures the photo on their device, and we'll upload those photos into our product if the user has the backup feature enabled. And of course, backup is one of our most popular features because it enables users to have the trust and peace of mind that their content is safe. And so backup happens in two phases. First, we upload the actual bytes of the media into our encrypted blob storage, and we use GCS for that. Next, we upload and encrypt the metadata into Spanner, things like the EXIF data from the images, the file name, and other product-specific metadata. And so at that point, we've got the content, we've got it safely stored, and users trust us with their data. And so we take privacy and security, reliability incredibly seriously. So uploading the content and the metadata into the Spanner and GCS is just the tip of the iceberg. At that point, a whole bunch of asynchronous processing kicks off. And this is all of our machine learning and all of our inferencing. And all of that processing is funneled around Spanner, which is the hub for our machine learning workflows. These machine learning models power our features to organize, to enable search, and reminiscing. And latency is very important for us so we can deliver these features to our users shortly after upload. So let's take an example. Let's say that I was out hiking the other day and wanted to search for that photo of a waterfall. And given that this is a presentation with Google Photos, I had to include some of my own photos as well. So there's a selection of my waterfalls. So after a photo is uploaded to our system, we queue that photo up for various forms of that offline image processing. ML inferencing that helps us label, understand, and organize the user's media into the library. We infer the semantic contents of an upload and understand both at an individual level, but also at an aggregate level about how that piece of content fits into the overall library. And to do that, it involves many large, complex Spanner queries that happen concurrently with many other reads and writes that are running on that user. So we have this asynchronous processing. Meanwhile, the user continues to browse and share and edit within their app. And so having those different read and write workflows happens concurrently is a key part of the design principles that Spanner enables here. So once we've done that in machine learning processing, process those signals and those labels, we store them back into Spanner, and then we index them into our downstream indexing system to enable for our search use case. So we can find those photos of a waterfall. So overall, this is a reasonably conceptually simple architecture of uploading content into our backend, storing in our blob storage and our database, and having some of that asynchronous processing. So overall, it's got a simple mental model, but that's really just the tip of the iceberg because we have over hundreds of binaries and microservices and processes to deliver on our product goals. And all of those microservices have different access patterns that range from small lookups to large data scans with a variety of latency and reliability requirements. Spanner has met every requirement we've had off the shelf. It's been incredibly flexible, easy to use, especially given our massive scale. As an example, we have a global user base, and users like to organize their content into albums and share them with each other. And so that type of cross-user sharing requires seamless real-time sharing, and Spanner's global indexes help us deliver on that goal. So I've walked you through a bit of the system diagram of Google Photos. And I wanted to kind of step back and highlight a few of the guiding principles that have carried us forward as we interact with Spanner. And I want to use kind of a fun, silly little castle metaphor to illustrate some of that. And in case you were wondering, yes, the castle is AI generated. So Photos continues to use a single unified database to power our application. And this is the foundation of our castle. It's the rock that we've built on. And so despite our large size and growth in both users, items, and queries per second, we've been able to continue to sustain on this single unified database architecture, navigating through our global needs. And that's yielded a simpler development experience, a more maintainable architecture, enabling us to lean into microservices, navigate and manage our technical debt, and support a tight release cycle. So many of the principles that and the tenets that Chris laid out earlier, we've really seen them flow through in our usage of the product. Our next principle is around strong consistency and high concurrency. And so these are the strong walls of our castle. We have strict consistency and concurrency needs, and that makes sense when you think about that mix of workloads I talked about, the asynchronous batch processing and the interactive user reads and writes of the product, having that happen together concurrently, as well as the cross-user nature of our product, where users love to share their content and having that cross-user consistency that's important. And so Spanner's high write throughput and consistency guarantees, resource management tools allow Photos to build and scale these features and pipelines by over 10x with minimal re-architecture. So we've really hit that goal of kind of future-proofing our further growth. And our database is user-centric. And we lean heavily on that asynchronous processing for efficiency and latency reasons. So overall, we're able to kind of deliver on all of that complexity of the hundreds of microservices while still delivering on our product goals. Coming back to kind of the enabling of those ML workflows, data needs to flow in and out of our castle, our data. We have that rich set of ML-powered features that rely on our ability to understand the semantic content of a user's content and their overall library. And so again, going back to that search example, we have a wide variety of signals that we label each content around and store all that information in Spanner. And using those signals and a variety of other metadata, we associate across these contents within an account to determine the most meaningful moments for a given user. And all of this functionality requires different database workloads. We've built a queuing system on top of Spanner that allows us to reliably process those work items. And for the search example, again, we have a variety of scans, lookups, point lookups, and joins at search time. Our memories feature, which kind of has a collection around a trip or a moment, requires large scans, secondary indices, and additional tables with derived metadata to power that. We also do clustering, like clustering of a thing or a person, and those operations require us to look at all the photos within a user's account, combining large scans and streaming approaches. So despite the wide variety of kind of workloads and different needs here, Spanner is able to meet all of this completely off the shelf for us. I mentioned that privacy and security is at our core. We really need to deliver on a user expectation of trust, privacy, and security. And that's the layer of protection around our castle. Users store their most precious moments with us, and so we want to ensure that data is encrypted at rest, tightly access controlled to protect against bad actors and unauthorized access, and that the security and privacy best practices are kind of baked in from the core so that we can confidently execute on additional features. And we care incredibly about reliability as well. And so we're confident that users' data is always available when they need it, with a variety of data integrity checks, as well as backups for disaster recovery. Our final principle is around operational excellence. And so we're proud of running a tight ship on top of Spanner. And so we've got our flag on the castle flying high there to celebrate that. Spanner has significantly reduced our toil. We save a ton of time and energy on tactical placement, location distribution, sharding, scaling, redundancy, backup management, all of the things that lets us focus on delivering the value to our users and not managing our infrastructure. And so for replicas, we input the specs and let Spanner handle the change in replication with adding and deleting shards. The self-healing nature of Spanner, such as automated index verifications, sharding, draining, guaranteed data consistency across regions, saves us a ton of work. And so we rely on Spanner to automatically replicate data with 5 nines availability, ensuring our users are confident their data is always safe. And that same spanner sharding allows us to roll out incrementally and observe how changes perform, which is a big win for our reliability. So kind of wrapping up on the principles, you can see them around having a single unified database, strong consistency and high concurrency, enabling our ML workflows, private and secure by default, and operationally excellent. All that has helped us deliver an amazing product. Google Photos has seen amazing success running on Spanner, and the numbers speak for themselves. With over 1 billion users, over 4 trillion items in our corpus, Spanner plays a huge role operating at that scale. Photos has experienced 10x growth since onboarding onto Spanner, and we're confident that we can scale another 10x. And so it's really exciting what it's allowed us to do, and we can't wait to continue bringing more amazing features to all of our Google Photos users. Thanks. Now back to Pratibha to wrap us up.
Thanks, John. Thanks for giving us a breadth look at what you do with Photos. Amazing partner for us. Hope during the session you found why Spanner, what we did with Spanner, what we do with Spanner inside of Google, and amazing partners like Google Photos who leverage Spanners to grow their business and delight the customers. So I just want to leave you with the amazing experience that we give to our external customers, our internal customers. As you're transforming your businesses, let us be your partners. Let's work with you to kind of bring your workloads onto no compromise cloud Spanner. With that, thanks for your time. Thank you.